So, as always, read the question carefully. We're given 4 points and their position vectors. The fact that the fourth one is made up of adding the previous vectors may or may not matter. But what they're asking us to do is find the position vector of the point E on the line AD such that it splits in the given ratio 1 to 2. So if we were going to do a sketch of this, then we could have the point A here and the point D here, and then we'll join them up, so that's, and then split them into the ratio 1 to 2. So that'll be roughly there. That's going to be point E, and that length will be, we'll call it alpha, and that would be 2 alpha. So that's what they wanted to find. They wanted to find the position vector of E. So if we decide on an arbitrary origin, what we've got is vectors going up there, which is A, up there, which is D, and then we have our E, which I don't know why, but I'm going to change to red. It makes it look nicer. And that is going to be our vector E. Now, for answering the question, we're going to use a formula. We'll look later on at the derivation of that formula, and I would suggest that being able to derive it is a good idea for various reasons. 1, your mathematical knowledge and development. 2, it means that if you forget the formula or can't quite remember it, you can work it out in an exam. And 3, because it's quite beautiful. So the formula is that to get the vector OE, which is the vector E, we have to do our first number, 1, times our second vector, our second number times our first vector, divided by our numbers added together. So now we can substitute in for what the vector little d is, and of course little d is A plus B minus C. That's what we're given. So that's going to be A plus B minus C plus the 2A divided by 3, and we'll take the third out because it looks better, and that gives us 3A plus B minus C. Now, in order to check a question like this, it's very, very difficult. Whether you'd ever have time in an exam is debatable, but I will show you how, just in case, and in case you're interested. So I've redrawn the diagram, and what we have is we have our original A, B and C in black here, and then blue for the B and red for the C. And what we can do with this answer we have is to write it slightly differently. So if we get rid of the fraction, or get rid of the bracket rather, we have an A plus a third of B take away a third of C. So in green now, if we actually roughly do that, if we do our A, that will take us up to here. If we do a third of B, that's roughly there. And then if we take away a third of C, so that's C going in the opposite direction, then that does indeed take us to E. So we can see on this rough sketch that our answer is reasonable at least, it's not completely mad, and so we could be happy with the answer. Now, as promised, we're going to have a quick look at how to derive the formula for splitting a line into a certain ratio. So, if we say we have a point A and a point B, and we want to split that in a ratio of lambda to mu, which is traditional, and we're going to call that point P. So again, we can say arbitrarily we have an origin, and that's therefore the vector A, and that's the vector B, and then we have here the vector P, where P equals OP. So, in that case, in order to get from O to P, we can think of it as first going from O to A, and then A to P. Now, if we look at the lengths of AP and AB, then we can see that the ratio, so notice the AP is not underlined now because now it's not a vector, it's the length of AP. So AP over AB will be lambda over lambda plus mu. That means that the length of AP is lambda AB over lambda plus mu. And since AP and AB are in the same direction, then we have AP as a vector is lambda over lambda plus mu times AB as a vector. Now, a quick aside, and this very important vector matter, is that if we want to find out what the vector from A to B is, then what we can think of is we travel to O, and then from O to B. So we go from A to O, O to B, and that will give us A to B. Now, going from A to O is minus A, and going from O to B is plus B. So that means that we can write AP equal to lambda over lambda plus mu times B minus A. Okay, so now we can go back to our original equation up here, and we can substitute in what we know. So we have OP equals OA is just little a, and then we've just seen that AP is lambda over lambda plus mu times B minus A. And then if we make lambda plus mu a common denominator, little a has to be times by lambda plus mu, and then we have our lambda times B minus A. Now this can then be simplified by getting rid of all the brackets. So what do we have times by A? Well, for A we have a lambda and a mu and a minus lambda, so that just leaves us with a mu times A, and for B we only have the lambda times B, so that's a plus, so that's going to be plus lambda B over lambda plus mu, and then we tend to want to have the lambda and mu in order because of the order of the ratio, so we would say lambda B plus mu A divided by lambda plus mu. Now, it may seem that's a lot to do, but actually, if you work through it carefully so that you understand what's happening, then it's actually relatively quick to jot down in an exam if you needed to, if you couldn't quite remember the final formula. The other thing is that actually as you start to write down what's happening, it might prompt you to remember the final formula. So in Geogebra we can have a look at this question. I put random A, B, C points and then the vectors, and then we can have a look at what D will look like. So there's D, and that comes from the end of A we add a B on, and from the end of B we add a minus C. So that takes us to point D, and therefore that's why the vector D is up there. Okay, so it's all looking a bit crazy already, but if we now put the vector in that joins A to D, there, we can see how we get the point E, which is a third of the way along because it splits in the ratio 1 to 2. So what that means is we need to travel from our answer, we've got an A, and then on the end of there we have to put a third of B, which is there. Just move the label out of the way a little bit. And then we need to put a third of minus C. And notice C is going in that direction and minus C is just the opposite direction. Same direction, but opposite. So we now put the extra minus C over 3, or minus a third of C, and that takes us to this point, E, and I think we can see that that is a third of the way along. And there is the vector for the point E. So that's what it actually looks like, which you wouldn't be expected to do in the exam. As I showed during the answering of the question, we could do sort of a little sketch that shows that it's reasonable, but nobody would be expecting accurate drawings because you're not allowed to use things like Geogebra in exams, which is a shame, but probably will come in at some point in the future. Okay, now to highlight E, we'll give it its own point. So there it is. And now, this is the sort of fun thing you can do on Geogebra, is we can play around with our original A, B and C vectors and see what happens. So we just do a very gingerish sort of shrinking C, we can see that it moves in like that. We could perhaps change C around, rotate it around. But what we can see is that the vector relationships remain the same. We still, when we have it like that, we still have our A plus a third of B minus a third of C, taking us to a point which is 1/3 along the line AD. And these sort of extra things you can do for yourself. Virtually everyone listening to this will be a lot younger than me and will have grown up using apps and programming and so on. Geogebra is not too difficult to use. There's loads of help, as you might imagine, on the internet, so I'd encourage you to have a go. We recommend using Classic 5 if you're working on a laptop or a PC, but the apps for tablets and phones are pretty decent as well.